All right, we're going to start Unit 12. We're going to start Unit 12 with talking about different interest formulas. The first interest formula we're going to talk about is simple interest. So our simple interest formula is interest is equal to principal times rate times time. Now, when you use your simple interest formula, a couple things you have to be mindful of. First thing is when you're talking about rate, so this is given to us as a percent. So we'll say something like 5% per year or 6% per year. You always have to take that percent, whatever it is, and change it into a decimal. And the way we do that is we locate the decimal and we move it twice to the left. Our T is our time, and our principal is the initial amount that we're starting with. So if it's a money question, it's the amount of money that we've initially invested into the account. Now, if we want to find out how much money we would have after a certain number of years, we would take our principal and we would add our interest rate. Now, most places will use something called a compound interest. So our compound interest means that you're earning interest on your principal amount plus your interest from the previous year. So compound interest formula looks a little different. Your compound interest formula is principal times 1 plus r over n to the nt. All right, so we have another variable here. We have n here now. So our r is still the same. Our r is still a rate as a decimal. Our n is the number of times that we're going to receive the interest per year. So they will say things like quarterly or monthly or semi-annually. That's our n value. And our t is the time in years. So our P is our initial amount. Our N is the number of times per year. If they say quarterly, it's 4 times. If they say monthly, we're getting it 12 times a year. If they say annually, we're getting it once a year. If they say semi-annually, we're getting it twice a year. And then our T is our time in years. All right, now our last type of interest is when you receive interest continuously. So if you receive interest continuously, we have our last formula, which is A equals principal times E to the RT. Sort of looks like PERT, so sometimes people call it the PERT formula. Our P is still our initial amount. Our E is a constant value. That's 2.71-ish. Our R is our rate as a decimal still, and our T is our time in years. All right, so let's look at a couple questions involving money and using the interest rate. So if you flip to the next page, page 5, we'll look at the first question. Okay, so the first question says, Kathy deposits $25 into an investment account with an annual interest rate of 5% compounded annually. She makes no other deposits. I should say withdrawals too. How much money will she have after 5 years? All right, so we have a compound interest formula. So we're using A equals P times 1 plus R over N to the NT. She's starting with $25. So that's her initial or her principal amount. She's receiving 5%. So 5% changed into a decimal, scooping it twice, gives me 0.05. She's receiving the interest annually, which means she's only getting it once a year. So notice those numbers are always the same. And she's going to leave her money in the account for 5 years. So 5 goes here. All right, and then at this point, we're just going to use our calculator. So I'm going to write 25 times 1 plus, I'm going to use the alpha y equals button to make a fraction, 0.05 over 1 raised to the caret 5 times 1, or just 5. Okay, so after 5 years, Kathy is going to have $31 $2,292.91. All right, let's see another one. Let's check out, let's skip 2. Let's do another money question. Let's go to 3. Okay, so number 3 tells us that Addison is going to invest in an account paying interest rate of 5.6% compounded continuously. So as soon as I see that word, I know I'm writing the PERT formula. Okay, my interest rate is 0.056%. How much would Addison need to invest? How much would she need to invest to the nearest dollar? Find the value of the account to reach $19,400 in 12 years. Okay, so this one's a little tricky because they didn't say that she started with $19,400. They say she wants to have that amount. That's her final balance. So because she wants her account to grow to $19,400, that's going to go in the A spot. So I'm looking for my principal amount. This one's a little tricky. Okay, my rate goes in as 0.056, and my time is 12 years. All right, so I'm solving for P. So this is just a numerical value because E is a constant. So I'm going to find out what that equals. Because I want to raise e to an exponent, I'm going to press second ln. That gives me e to the x. Then I'm going to type in 0.056 times 12. Okay, so this whole thing here is just equal to 1.958149706. All right, now I want to find P, so I just need to divide this number to get P by itself. Okay, so now when I type it into my calculator, I still have that number on my screen. I'm going to type in 19,400 divided by, and I want to use that answer because I don't want to round in the middle of the problem. So I'm going to press second, negative symbol. See how it types in as 19,400 over answer? Okay, and I find out that Addison needs to start with $9,907.31. So if Addison invests this amount of money in the beginning, it will grow to $19,400 under these conditions. All right, let's check out one last question. Okay, let's check out number 4. Okay, so number 4 talks about 2 different people. It says Kaylee invested $59,000 in an account paying interest rate of 5.75% compounded monthly. And Joe invests $59,000 in an account paying an interest rate of 6.25% compounded continuously. After 13 years, how much more money would Joe have in his account than Kaylee to the nearest dollar? All right, so we have 2 different accounts, 2 different conditions. So I'm going to start with Kaylee. Okay, Kaylee has something that compounds continuously. So because she chose an account that compounds continuously, I'm going to use A equals P times 1 plus R over N to the NT. She starts with $59,000. Her interest rate is 5.75%. So I have to change that into a decimal first by scooping the decimal twice. So 0.0575 over. She's receiving her interest monthly. So that means she's getting it 12 times a year. She's going to leave her money in her account for 13 years. All right, so we're going to type this in. We're going to find out how much she has after 13 years. So we have 59,000, parentheses, 1 plus alpha y equals 0.0575 over 12. Close the parenthesis, caret raised to the 12 times 13. Okay, so Kaylee has $124,368.91. All right, let's check out what happens with Joe. Okay, Joe picks an account that compounds continuously. So Joe is using the PERT formula. He's starting with the same amount, which is 59,000. The E is a number, so that stays in there, E. His rate is 6.25%. So I have to take 6.25% and change it into a decimal. And he's leaving his money also into the account for 13 years. All right, so now we're going to type that in. So we have 59,000 E, so second ln, 0.0625 times 13. All right, so after 13 years, Joe has $132,958.55. Okay, this question, if you remember, says how much more will Joe have? So I have to take Joe's amount and subtract Kaylee's amount. And that will tell me how much more Joe has. So I have $132,958.55 minus $124,368.91. So Joe has $8,589.64 more than Kaylee.